So we start with the questions. A, B, and C. Okay, the question is find the condition of A, B, and C for which y is equal to 1.
So that's y is equal to 1 or low.
1, 1, 1.
1. Okay.
Sir, A dot B.
I am asking the condition of ABC, not the equation.
A will be equals to B. and that will be equals to 1.
Okay. So A is equal to B and that is equal to 1. And what about C?
C is independent. You can take anything.
Okay. So C may be 0 or 1. Any other? Same answer?
Sir, I'm getting A, B, A can be 0 or 1, B can be 0 or 1, and C is not. The final answer that I'm getting is A plus B, the equation. So
A plus B. One is getting the A dot B. Any other? Okay. My output should be 1. Okay. So that means this and this both will be 0 because it is a NOR gate. When both input is 0, then output is 1. Okay. That means here we are getting 0 and here we are getting 0. In the NAND gate, if we are getting AND gate, we are getting 0. That means this one is 0, this one is 0. Okay. From here we are getting 0. So this one is 0 and this one is 0. Sorry. This one is 0 and this one is 0 because this is a NOR gate. Oh, sorry, OR gate. In the OR gate, output is 0 when both input is 0. If this is 0, so that means this one is 0. Now this one is either 1 or 0 because it is a AND gate. Okay, in the AND gate, if both input will 1, then output is 1, otherwise 0. Okay, so input, this second input is maybe either 0 or maybe 1. If this is 0, so that means A is 1 and B is 1. And if this is 1, that means A is 0 or 1, B is 0 and 1. Okay, now the thing from here. This part is 0. Now AND gate, this is the AND gate. Okay, if output is 0, that means this is the either 0 or 1, or this is 1 or 0. Okay, now if we is saying that this is a 1 or 0, so that means this particularly data will be either both are 0 0, both are 1 1 or 0 1 1 0, any data we can take. Okay, so the condition is all possible 8 outputs A, B and C, 1 1 to A 0, B 0 and C 0. In all the condition we are getting a output Y is 1. Okay, we can verify this one by creating a truth table A, B, C and Y. Zero 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 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. You can take any of the input and check what is the output. Okay.
Sir, from an exam point of view, like time wise, what's the most efficient way to tackle this sort of? Should we find the equation first and then go ahead, or
Yeah,
should we?
better that you can find the equation first. The thing is that if you have enough time, okay, so in that scenario you have to verify, because if you are going to the competition exam, so there are basically the time limitation is in some exam time limitation. For
Right.
the similar to the gate examination, if you go okay, 3 hours time duration is there. Okay, so in that one you can create a equation. Otherwise you can verify with that output is 1, so you just go with the forward to backward approach if you don't have a time.
Okay.
Okay, because initially you are getting the equation, then after that you are checking which is the conditions. Okay, so it will be taking the time. Better is that forward to backward approach you can follow.
Okay. Okay, sir. Thank you.
If you have a 30x NOR gate, okay, so what is the output?
दो बार कम कम देखना भाई लैंग्वेज इजी नहीं एक्चुअली
That ground will get zero.
Yeah, ground is 0. That is the ground.
So we will get A.
The output is here.
Or A. Oh, sorry, sir.
Okay. A bar 1 and 0. Better than you can speak. Don't put in chat box.
I will get A
Okay.
Yes, sir, we'll get A.
because it's for even we get A and for odd we'll get A bar.
Okay. So basically the XOR gate, if we have a two input A, B and Y, 0, 0, 0, 1, 1, 0 and 1, 1. Okay, we are getting 1, 0, 0, 1. So the property of the OR XOR gate is that if one input is 0, okay, if we take a one input as a constant 0, we are getting complement of this one. Okay, so if you apply a 0, we are getting 1. If you apply 1, getting 0, 1, getting 0. So that means if one input is 0, that behave as a inverter. Okay, similarly, if one input is 1, then second input 0 is apply at 0, 0, 0, 1 and 1. That means if input is 1, then behave as a buffer. Okay, so here we are apply the input is 0, so here we are getting the A bar, then A, then A bar, then A. So after every odd number we are getting a bar, and after every even number we are getting a. Now the number of gate is 30, that is the even number, so we are getting output as a. Now what is the output?
Sir, the output is A bar.
So we'll get A.
A bar and A.
I'm getting zeros.
Oh, three different answer. Okay, so we are using the NAND gate.
When it's getting out of that NAND game, then we'll get A bar, and after that XOR, it's getting A.
Okay, let's check. So basically, the AND gate is the if A and B input is there and output is Y, 0 0 0 1 1 0 and 1 1. Okay, so this condition is not possible. Why this condition is not possible? Because we fix one input, A. Okay, so this is not possible. So we are talking about these three conditions. If any of the input is 1, we are getting complement of that one. Output as a complement of another input. Okay, so for 0 input we are getting 1, for 0 input we are getting 1, for 1 input we are getting a 0. So in the case of NAND gate, if any input is 1, it behaves as a NOT gate. Okay, and XNOR we already discussed. If any input is 1, we are behaving as a buffer. So with the help of A, if one input is 1, we are getting A bar. Okay, this is the XOR gate connected with 1, so we are getting A bar here, buffer, same output. Okay, again 1 behave as a NOT gate, so we are getting A here, and buffer we are getting same output. Again NAND gate we are getting a inverter output, and with the XOR gate we are getting as a buffer output. So A bar. So the answer is A bar.
Okay, sir. Sir, I think I made a mistake when I considered that B as 1. So
Mhm.
here. So if I ground it, then we always get 0. But since it is 1, then right.
For the NAND gate, if any of the input is 0, so I'm taking 0, 0, 0, 1, 1, 0, and 1, 1. So this condition is not possible if we consider one input as a 0.
Right.
Okay, so output is 1, 1, 1. Okay, so one input is 0. Okay, so if any input is 0, that behave as a always logical. Okay, not gate, neither not gate, neither buffer, neither inverter, only as a logic one. That means every time we are getting a logic one, either we are applying the second input as a 0 or 1, doesn't matter. Okay, so this is for NAND gate. This is for XNOR gate. Let's try one more, I think. These are total 41 gates. So what is output? Solve it.
Sir, output is A bar.
A bar.
We'll get A bar.
A bar.
A bar.
Okay, so everyone will be getting the A bar. Okay, so let's check. If we apply the A and this is the XNOR gate, so what is the XNOR gate says? If any of the input is 0, that behave as a inverter. So we are getting a bar here. Okay, second one is the XOR gate. What XOR gate says, if any of the input is 0, then behave as a buffer. So XNOR gate behave as an inverter. XOR gate behave as a buffer, and NOR gate. Okay, so we check with the NOR gate also. So the table of the NOR gate is A B Y 000110. Okay, 100. So if any of the input is 0, the second input that is applied inverter we are getting. If you apply 0, we are getting 1. If you apply 1, getting 0, 1 getting 0. So NOR gate also behave as a inverter. Okay, so third stage, this is the A bar, and third stage is again A. Okay, after that you are getting repeating this one. Okay, now we have a 41 gates. That means 13 combination of 3 gates, okay, plus 2 gates. 2 gates, which one? These two. Okay, so after every combination we are getting the same input that we apply. Okay, so if I am taking this as a block, if I am using this as a block, okay, so we are basically using a 13 block. Here we apply A, we are getting A. Again we apply A, we are getting A. Okay, so this is the 13 block. Now after that there are 2 gates. One is the XNOR and second is XOR. Okay. Now the important thing is that only these 2 gates. So here we are getting A. Now A bar, and that is A bar. This is the final output. So final output is A bar. Okay, so this type of question is generally asked several times in the GATE examination. The question is easy, but thing is that it will be tricky. Find the condition of A and B for which y plus b.
So we are always getting 1. I think y is always 1
Okay.
for all cases.
Any other answer? So we are getting 1 when either this is 0 or 1, or this is 1 or 0. 1 or 1. Okay, so it will be 0. This both will be 0 and it will be 1. Again 1. Yeah, for all the cases. Kindly check again with the equation. So this is the 1, so we are getting a bar here, and here we are getting 1 plus b, that is 1. Okay, at this point we are getting 1, this point we are getting a bar. So a bar at this point. Now a bar and 1. Okay, so we are getting a here. Sorry, this is we are getting a. So here we are getting a bar. Okay, now a bar and a bar becomes a bar, and a
So
bar.
that will be A, right? A and A bar, the top one.
Yeah, this is the a.
So there also will have A.
Yeah, this one is a. This one is a bar. Okay. Now a bar go to this point, so a bar plus 1 whole bar. So that is 0. So we are getting always a bar.
Sir, that OR gate at the top, that will be A, right? A and A bar.
Okay. Say a bar 1. Okay. So we are getting 1 here. So output y doesn't depend on, not a function of a and b. Okay. So any value of a and b is given, always output y is 1. Clear? Any doubts? So this answer is wrong. This is the correct answer. Now, if you have any doubt, you can ask. Everyone go through with the week content?
Yes, sir.
Okay. So I think your deadline is 22nd. Now we have a class on 18. So in the class 18, we start with the week 4.
In next class.
Yeah, next class. Okay, and we will do that. Our two last Friday classes. Okay, we have to schedule it this time. So we can do one thing is that Wednesday we have a class 2 to 3. So can I take it as 2 to 4? Okay. So 1 hour compensate here, and similarly we can schedule one class on Saturday. Morning 11 to 12. Is it fine?
Yes, sir.
Okay. So I will put this one in group also. So thank you all.